In this video, we're going to look at something called rational numbers, and we're going to do a review of number sets, which you may already know, but a little review shouldn't hurt. So a rational number is a number that can be written as a fraction. Okay, that's in Mr. Begg's words. So if you can write it as a fraction, it's rational. Simple as that. So, and by the way, rational numbers are a number set. They're a type of numbers, just like natural numbers, whole numbers, integers. You've heard these types of numbers before. Rational numbers are another kind. So natural numbers, we use the letter n to represent them, and those are the numbers 1, 2, 3, etc. No decimals. Or negative numbers. Whole numbers, we use the letter W to represent them. They're the numbers 0, 1, 2, 3, and so on. And those are exactly the same as natural numbers, except with 0 as well. So natural set plus 0. That's all you need to know for whole numbers. Integers, we're going to use big I to represent integers, although I've sometimes seen the letter Z used in other places. But for us, big I will be good. They go into the negative numbers, right? So they could go to negative infinity. I'm just going to stick around 0 here. But they have negative and positive numbers, and they include 0 as well. So the one thing they don't include is decimals. No decimals for integers. So we can think of that as whole numbers, the whole number set. And put brackets around, or quotations around it, so you know I'm talking about the name. So the whole set plus negative into negative numbers. But still, no decimals. Okay, rational numbers, the one that we just talked about, is we're going to actually use the letter Q for that. And the reason we use the letter Q is because R has already been taken by another number set called the real number set. And real numbers are basically any number at all that we can think of anyway. So we use Q for rational numbers. So they can be any decimal, positive or negative. Well, actually, not any decimal. Any number that can be written as a fraction, positive or negative. So it's the integer set plus some decimals. Which decimals? The ones that can be written as fractions. How can a number be written as, how do we know if a decimal can be written as a fraction or not? Well, decimals that terminate or repeat. So if you have a decimal that ends, such as 3.5, that ends, or negative 0.216 or whatever, as long as it stops somewhere, then it's terminating. We can write it as a fraction. Ones that repeat can also be written as fractions. For example, decimal 33333 forever can be written as a fraction. We know that one is a fraction. That's 1/3. 1/3, 1 divided by 3, is decimal 3 repeating. But if there's something that doesn't end, so the decimal keeps going, but it doesn't repeat either, we can't write it as a fraction. So for the most famous example of that is pi, 3.1415 and so on. Doesn't end, it doesn't repeat. That's an irrational number. We use Q with a line over top of it to represent that. basically, that line over top just means not q. So these two are connected to each other. So rational numbers can be written as fractions, and irrational numbers are just anything that isn't a rational number, so by definition, can't be written as fractions. So we have N, W, I, Q, and Q bar, and I also mentioned that R is the real number set. So we use big R for that. And we can think of that as Q plus Q bar. So since rational numbers include all integers, whole numbers, and natural numbers, and since irrational numbers include all numbers that aren't rational, that's basically everything. Not basically, that is everything. Real numbers are just everything. Q and Q bar. List all of the number sets to which the following numbers belong. All right, 0.26 repeating. So that's a repeating number. That means that it's a rational number, and if it's rational, then it's got to be an integer. Oh no, it doesn't have to be an integer. Sorry, got that backwards. That's a rational number. It doesn't have to be an integer. In fact, it isn't an integer because integers don't include decimals, but it is a real number. Okay, so it's going to include Q and R. 0.45, not repeating. That's still a rational number. Again, not an integer, a whole number, or a natural number. And it can't be both Q and Q bar. So as soon as I put Q down, I know that Q bar is out. But again, it's going to be real numbers. Pi, I already mentioned, is irrational. So again, it can't be rational. And if it can't be rational, it can't be any of the other N, W, or I. But again, it can be R. 5 is a natural number. It's also a whole number. It's also an integer, which makes it also a rational number, and of course it's a real number. So numbers can be in multiple number sets. Okay, here's a couple other examples of different types of things, such as express 4 2/3 as an improper fraction. Okay, we've already done this. We know that we multiply 4 times 3 is 12, plus 2 is 14, and we put it over the same denominator of 3. Express 12 over 15 in lowest terms. We know that both 12 and 15 can be divided by 5, so we get 4/5. Express 60 over 7 as a mixed number. 7 goes into 60 8 times, with 4 left over, so it's 8 4/7. The reason why we're reviewing all of these is because all of these numbers are rational numbers. They're all numbers that can be written as fractions, therefore they're all rational numbers. List the numbers in order from least to greatest. Remember, the least, if we're involving negative numbers, least numbers are the ones that are the most negative. Probably easiest to do this question if we rewrite them all as improper, or, well, improper fractions if necessary, so that we don't have mixed numbers, I think. Maybe you don't agree, but I'm going to do that. So I'm going to rewrite this so, not all of them, like 3/10 doesn't need to be rewritten, but 1 1/10 I'd rewrite as 11/10. And negative 1/10, I'm going to put that negative sign up top. And, negative 2/3, okay. And 1/2. I guess I didn't have much to change. I was thinking, at a glance, I thought I had more mixed numbers, but I didn't. Anyway, so the ones that go farther on the left, the first number on the left is going to be one of my negative ones, the biggest negative number. So ignoring the negative sign, I'm just looking at the 1/10 and the 2/3. 2/3 is a bigger number than 1/10, which means that it's actually more negative, and it should go farther left. And then my only other negative number is the 1/10, negative 1/10, so that should go next. Then now that I've got to positive numbers, I'm going to start with the smallest one and work my way up. So I got 3/10 and 11/10. Obviously 3/10 is smaller, but I've also got a half. So is 3/10 smaller or bigger than a half? Well, 5/10 would be a half, 3/10 is less, so it comes next, and then a half, and then 11/10. Or 1 1/10 if you want to leave it like that. Identify the values of A, B, C, D, and E in fraction form. All right, so for A part, it is between -3 and -4. When we're doing negative numbers, we're actually counting from the smaller one. So counting from -3, this is divided into thirds, so that's 1/3, that's 2/3. I would count that as -3 and 2/3. So A part is -3 and 2/3. Or as an improper fraction, remember I ignore the negative sign. 3 times 3 is 9, plus 2 is 11. Then I could put the negative sign out front, or on top. For B part, it's between -2 and -3, so counting from the -2, it's 1/3 of the way over. And again, if I want to make it improper, 2 times 3 is 6, plus 1 is 7. Put the negative sign on top, it's -7/3. C part is between 0 and -1. So once again, I'm going to start at the 0 and count down. Anywhere from 0 is my cutoff, right? So anywhere to the left of 0, I'm going to count down from that one. So I'm counting down from 0. I've got -2/3. I'm below 0. I'm at -2/3. And that one, again, I can't change. I can't make it into any different forms. I'd leave it like that. But again, notice the negative signs on top. Once I'm to the right of 0, now I'm counting up. So I've got 1 and 1/3, which as a mixed fraction would be 4/3. And finally, for E part, I've got 2 and 2/3. Change that to an improper fraction if I wish. 2 times 3 is 6, plus 2 is 8. So it's 8/3. And that appears to be that for this lesson.